We have now entered the realm where we have models that are so complex that we can't just explain it with a simple sentence. It's not like as x increases by 1, y increases by 7. And that's the way that simple linear regression is with that slope. So let's talk about the right ways to describe our curvature. So let's Control L my console so we can start over. We would have done a quadratic fit and looked at the summary in order to get this plot. Oh, good. Should we make it look nice? Yeah, great. And I'm going to want to save that to my clipboard because we will use it later. And just as a reminder, here's the prediction equation that we use to get that quadratic. And I want to start in red font because these are going to be bad ways to explain this. And before you laugh, this is really common. People are trying to explain each of these coefficients, so they say, okay, here's age. I guess we don't need to call it age hat because I only have it here to help remind us. And so they say, what is the effect of age? Well, the effect is 5.307. So as age increases, the speed increases by 0.5307. That would have been true if this was just linear regression and we didn't have that piece. But you've completely ignored the second piece, which means it's equally wrong to explain it with a sentence that says, as age squared increases, it drops. You've ignored that piece. And I emphasize this in class that you can't have only one piece that you're talking about when clearly age and age squared are connected. So some students try to get around that by putting both sentences in there. And they think, there, that fixes it. No, you've just made two mistakes together, right? Neither one of these sentences is actually true. That sentence is false because age squared has an effect. That sentence is false because age itself has an effect, which then leads some students to try to combine them together into one big sentence talking about both at the same time. No. First off, this is a complete thought which is false. And second off, what is an age squared? Can you describe an age squared for me? I can square my age. I don't like the number I get. But no client out there wants to try to think of their data in terms of the units squared. We've hit the part of the class where you're not going to be able to describe the effect of these variables with some simple sentence that just uses this number. This is more complex than just these numbers. Sometimes students will go way the other way with way too simple. As age increases, the speed drops. Well, I guess that's true, but you could say that about all these graphs, and they're very different. This is more like our graph, whereas this one is kind of completely opposite, and it could matter to a client. Are they dropping in steps? They might want to know. And so that's way too vague. And sometimes students will try to talk about, okay, here's where it ends up. That still doesn't tell me how it gets there. That curvature matters. Then there's this one, which is actually a true statement. The effect of age is that speed is related to age with this equation. But unless you're a real math nerd, this equation is going to be hard for you to visualize and understand, and a client is going to want you to explain more than just giving the prediction equation. So what can we do? What are some good ways to describe this? Well, here I'm going to describe that the speed doesn't drop much as you age until about 3 years when it starts to drop more. And if that sounds vague to you, it's okay because you have that picture, which is going to cover a multitude of sins. And here's another one that might seem even more vague. As you can see, the older the process, the slower the speed, and it's more pronounced for the older ones than the newer ones. But this sentence really shows that the person is understanding what these variables mean. This is old processors, here's newer ones. The newer ones are still dropping in speed, but not a whole lot. The older ones are dropping in speed a lot. So I would like to see a sentence like this because you're thinking about not only what are the variables, but what's the implication here. And if you want to put more detail into it, you can. As you can see in the picture below, I'm just showing different writing styles. But at 1, the speed's about 100, and then 2, it drops to 90. 3, we're dropping in the 80 range. 5, we're looking at 60, and by 6 it's down to 40. You can actually put in those little numbers, and as people read that in their mind, they're plotting this curve, plus they can actually see the curve. This would be fantastic detail for a client that really wanted to understand this and was having a hard time. So this would be a fantastic way to write about it, although any of these would be acceptable. But from here on, when we try to describe this curvature, we're not going to want to describe the effect of age itself or age squared itself. We're going to draw a curve and show the client what that means. Let's look at another example and see if we can throw in the categorical stuff that we did in the last chapter.